Do I need to? Hold on. I need to. So now.
Yeah, now it's just.
I just prepare myself a little bit here. Slideshow, which primary monitor, presenters view, and start. Good. So first of all, I would like to also thank all of you, yeah, for the great job you have done. Such problems you have, typically in logistics every day, yeah, and it's also, the picture is also changing every day. So this means this is now, by taking a look to a helicopter to such a topic. We said, do not touch the RDC. In real life, you could also even touch the RDCs, and then you realize how complex things are becoming in that. And you are not, most of the companies, what we experience is that some of the companies, they do this really quite often, such topics, and also trying to keep the gap between the as is and the optimal, or the should be, yeah, quite close. This means also that we need to be flexible in future. Yeah, for example, if you build your own warehouse and you put them there and you invest millions, this is something you cannot change quite quickly. And so you are in a structure, yeah, long term you are in a structure, and in parallel the real life is changing. So the gap between where you are and where you should be, or where a company should be from an overall setup, is getting bigger and bigger, the gap in between. And that's why it's always good to permanently readjust, and to permanently come closer to that. Yeah, also in order to have less implementation and startup costs on that. As the bigger the gap is, the bigger the challenge will be in order to change. So in here, what we have done, we said, okay, let's make a simple case upfront, not touching the customer, not touching the RDCs, not doing multi-stage and whatever, as this would be, this would just let it explode. However, we found out also on your side, you realized it is complex. Yeah, such topics could be complex. Not just only about that. I have many other cases with me, which can be solved, which are also complex in logistics. Yeah, it doesn't matter if you talk about the SKUs need to be assigned to the right bin location in the warehouse, or the truck needs to dock at the right gate in order to have less cost. Every problem is by end of the day an optimization problem and also an forecasting problem. We have not covered this, but the combination of both is in principle the high-end world in that analytics area. Good. So and now I made the same mistake as I need to swap. Yeah. So in order to do so, just now I have on which screen I'm here. I put this over there. So in order to do so, I would like to, and whenever we take it up, what is important to know a little bit theory upfront before I go in, and before we demonstrate what we have done and how we have done it. First of all, from an overall approach, and we saw a lot of ideas, a lot of things in that. What is important in such projects that you follow a clear approach and clear methodology. This means, and what I missed a little bit in most of the teams was a clear baseline. Yeah, to say, okay, well, what do we have today? What does it cost today? Before I do any optimization or something like that, I first of all need to take a look. What is the current situation? And I need to have a reference line. Yeah. So the baseline part, we have not. Maybe did somebody present the baseline on as is costs and so on with savings? Yeah.
Yeah, so I felt that there are teams which has presented the baseline, but not in the beginning. So the teams, what they've done is, in the beginning they have mentioned the theoretical as is, and in the end when they have the 2B scenario, they've compared it with the as is numbers. So there are teams which has worked on the as is as well, but compared it with the 2B scenario in the end of the presentation.
Yeah. Exactly. So this is something which is important. As a second part, whenever we take in a more detailed one, and maybe I do it on that side first. And baseline calculation is always on a detailed level. This means in the real life, you have in the baseline, for example, real shipments, real delivery notes, delivery note lines, whatever. This is in simulation. You can go really deep. In a design mode, so whenever you start optimizations and such topics, you permanently downsize the model. Yeah, so you go for average shipments and average, so customer with average shipments and so on. And for all of that, there is maybe, whenever there is a design outcome, as it was downsized, this means also the target value which comes out of a design, yeah, is downsized, and therefore it is needed to make a detailed level afterward to evaluate it again on a detailed shipment level, on a detailed level. But this is just generals, yeah. And this means that whenever we take a look to it, yeah, that in the baseline we take first of all the geographical analysis, cost evaluation. So a lot of things, of course, we have shared in the slide deck. Yeah, in the case itself, the design, now in the design, there are many things possible. Either you just over jump that and you go immediately in the evaluation by meaning, I do have an idea. And I would like to know, I strong feeling that this idea is, and you immediately simulate an what if. Or could be different things, or if the problem becomes too complex, then of course you can go in a design solver. Yeah, and you can get some support on that to take a look to it, or either you do a fully heuristical basis, or you do just a simple center of gravity. But there are some side effects which we need to take care of, or you do full mathematical optimization, as many of you has done it. Yeah, important is then, and this is the importance of it, due to the fact that, and I just remind, from the baseline to this design, we somehow describe a solver. We maybe need to downsize it. All of you or most of you has used a different approach on that, and also in case there was a solver involved, you use different solvers, yeah, or possibilities. And so before we open a solver, we permanently in design approach, we permanently start calibrating the solver. This means we have here calculated the baseline, then we try to configure the solver that out of a solver, the as is situation is coming out of it, and I should get out of the solver somehow similar, the same results than what I have in the solver, in the baseline. So and then I know, okay, the solvers and all the numbers and everything what I put in there is somehow correct, and this is and then you can finally yeah, you can trust the solver in the first instance. So you can create scenarios in the solver, but if there is an outcome, then, and this is what I mean, then it makes sense also to evaluate the outcomes. Yeah, so to taking the results, to evaluate the outcome, and to go into that and to do an evaluation phase. Yeah, by end of the day. And then of course, yeah, you can different scenarios, you can create different scenarios and maybe compare it also. Yeah, sometimes it's also good to compare. And I show you an example on that, why it is good to compare and not just to take the best out of it. Yeah, as there are also some side effects which plays a role. Yeah. Good. So another one is where is my, just a second. So I lost the, hold on, I just need to, okay, let's do it like that. Oh, I lost my presenters view.
So while Dirk, you're doing that, I just like to add one more point regarding the solver option that you have given. So there is also one more benefit. So one is to check the accuracy level of the solver by directly running it on the as is scenario. Number two, there are some complex solvers which has a lot of constraints inbuilt in it, and sometimes your as is scenario needs to be adjusted. So that also makes it important for the analyst to run the as is scenario on the solver, so that now with that output you have the adjusted as is scenario, which means that whenever you're running a 2B scenario, you're not comparing your 2B output to the actual as is scenario. You're comparing your 2B output with the adjusted as is scenario. So that also that is one of important reasons why you should always run your as is on any solver as well.
Exactly. So now I have it again. Was just disappeared. I found it again. So this is exactly the point what Ritek has mentioned, to keep a little bit control and also to take maybe to the left and to the right what you are doing. Yeah. So let's take a look to some generic topics. Very, very simple, just generic case theory. You see in the as-is, you have direct flows. So there are direct flows from a source to the target. Let's say from the suppliers to the warehouses. Let's take a look to the positive aspects of that. And this is the as-is situation what we have just described. The positive aspects of that is we have no deviation at all in kilometers. So the shipments, they just go direct. If you sum up all the kilometers what the shipment has driven by end of the day, it is for the shipment itself, it's quite less for every shipment. So there is no deviation at all. Yeah. All shipments and transportation, so the transportation demands goes direct. This is the positive aspect. The negative aspect is we do have small shipment sizes. What does this mean? We come to that. We have a lot of trade lines. In this case, we have just 16 trade lines. Yeah. In our case, what we have shared, there was about 1,600 trade lines. Yeah, 1,600 trade lines in our transportation lanes. Yeah. So what happens if I now put just one CDC in the middle? If I put one CDC in the middle, this means I do have also some positive and some negative aspects. Yeah, the positive one would be I do have less transportation lanes. So in this case, just only 8. In our case, yeah, you can sum it up. You have the trade lines from the suppliers to one CDC, which is how many suppliers did we have, Ritik? Just
117 suppliers and 3 production plants.
So 174 plus 14 warehouses. So let's go for 200. This means we have here 117, 175, and here another 20, let's say. So overall we have 200. So in the baseline we have 1,600, and in a central DC we have just 200. So we reduced the transportation lanes from 1,600 to less than 200. And by doing so, of course, we have a much higher consolidation. And by doing so, with a higher consolidation, we have a lot of transportation going out, and there is also stock maybe in the middle, but also there is no need for doing stock. You can also just make a cross-stock solution out of that. Yeah, but of course, with the stock, you can also, if you have a buffer stock, then you can move the transports back and forth in time. Yeah, so this means, and if you're doing so, then you can, if you consolidate, then you can go a much higher frequency instead of managing 1,600 trade lanes, transportation lanes individually. So maybe for the 1,600s, there are trade lanes where you have just 1, 2, 3 shipments. If these are annual volumes, then this means every 3 months, every 4 months, you get from this supplier a replenishment purchasing order. Yeah, and on the other hand, if you super streamline it and consolidating it, you can go an even higher frequency on that. So these are the positive aspects. This is hub and spoke systems. Which business, which industry has installed the hub and spoke systems first? What do you believe? It was not in the logistics area. It was in the air freight area. So the passenger transportation in the airlines, they have invented that. They have started doing such hub and spokes. Said, okay, well, if I have some hubs, they have started with doing so. And a few years later, logistics industry, they also took it up. But it has also some negative aspects. Let's take a look to the negative aspect. Negative aspects are, we have a high deviation in kilometers per shipments. Of course, we do have trade lanes, and we take a look to it where the gap is bigger, or where the deviation is bigger, and some others it's smaller. And we have also a double handling. This is also what we have. However, if you have them all here in store, you get it also much quicker to the CDCs. So this means that and all of those aspects we have not put in scope into this case, and we have also not talked about that yet. As if a regional DC is placing a replenishment order at the suppliers, and maybe the supplier is doing it build of make to order, then it could be they have a little bit production time. It could be they have long transit times in between. If you have a stock in between, it's already there. So this means you have just one or 2 days or 3 days in between for getting it out of the central DC. This means if you're doing so, it has a high influence in the stock policies in the regional DCs. As the stock policies is also, if you optimize that, it is linked to, and it has a correlation to the overall transit times in replenishment times. How long does it take to get it in again? Yeah, so you can downsize the stock level. So there are a lot of aspects which we have not put focus on, which we just ignored for the time being. This is typically, it's normal also in all of those optimization projects. There are points where which you do not consider for the time being, but you need to know it. You need to have it in your back mind, and that's why it's always good to take not just one solution, but to take a look to left and right and see what's the best out of it. Good. So let's take a look to the deviation. Case 1, case 2. This is the negative part. Yeah. In the case 1, either we go direct or we go indirect via a warehouse. So in the indirect one, if we go here via a warehouse, you see it. In this case, the deviation is more than 100%. This means the kilometers what the shipment has put in the log is more than double so high. Yeah, it depends. It really depends to how the geographical setup is by end of the day. But this makes only sense for smaller shipments. I see quite often in a lot of, they have static rules. They say, okay, everything which is above 2 tons, I go direct, and below 2 tons, I ship via a central hub. No, this makes no sense. As this is a dynamic and it needs to be balanced. This means, let's take a look to the case 2. In case 2, maybe for this one, there is no deviation at all. It's just the warehouse is just on the way. So if we have if I would have a transport in here with 8 tons, for this transport, it would not cost too much more if I just route it via a warehouse. But maybe there is another one which with just 500 kilos who can jump on that. So what do I mean with balancing it? I mean with the overall shipment size and the deviation is in correlation. The bigger the deviation is, the smaller the shipment can be that I still go this way. The bigger the shipment will be, the less deviation I should have. And this means also if you now do a setup on that, maybe you do a setup where you, by end of the day, take a look also to let's say, and where you say, okay, which are routes through a warehouse and which, for which one it doesn't make sense at all. And you just leave it out. Questions so far to that? From anybody, from somebody? No, otherwise you just hands up or put it in the chat, Ritik, and takes a look to it, or franjali, and she will inform me on that if you have a question. But you can also interrupt me at any time. The next topic, why consolidation is that important, and this is what I just mentioned in here. Yeah, if shipment, maybe I have capacity 10 tons, and I do have in transport orders 8 tons, yeah, which just running through here. Maybe for the 8 tons, I also pay the FTL cost, so there is no big difference. But another shipment, what I mentioned, jumps onto it in the hub and get, let's say, for free and transit possibility. Yeah, and why for free? As the costs in transportation are not increasing linearly. We don't have, there is something missing. Sorry, this one now. We don't have, costs in transportations are not increasing linear. So this means we have always cost curves like that. Yeah, where you pay, for example, where you have 50% of the fill rate and you pay already nearly a full truckload. Yeah, and because of that, so this is important in all of the design projects. Transportation costs are not growing linear. And this means also that consolidation effects results in savings just by gaining scale effects. This happens in real life. Yeah, and those savings are quite big. I can show you examples in real rights. We have real rights, but this would just take a look to the time a little bit. But this would just be too big today. Yeah, they say, okay, I have 2 shipments. Yeah, every shipment the same size cost me 100, so overall I pay 200. If I would then ship together, I just pay 175. So this means I have immediately 13% savings immediately. In an area, in an industry where we have 1 to 2% turnover margin. This is a lot. And this means also the bigger the consolidation effect is, the more deviation a shipment can take. So this means if I'm on the lower level, I have a quite high delta, so I can go a lot of deviations and turnarounds. However, if the shipment is already big in that area, I don't have that possibility. So maybe those ones I need to filter it out also. Filtering it out, there are 3 possibilities in the approach. I mean, I showed you the approach in the beginning, yeah, baseline, design, evaluation. But you can also making it more dynamic. This means you can also say, okay, in order to downsize the design problem, I already filter some things out of it. I filter some out, which I really don't. I have here some FTLs already quite full, which are super locally, so I don't let them reroute. I directly filter them out prior. So you have an out filter, let's say, prior to a mathematical optimization. These smalling and case. You can also do then an mathematical optimization in design and do a repair afterwards and do a cherry picking afterwards. Also, that is possible. That you say, okay, well, this is now, and now I double check it again, and maybe there is something in which if you have not given the solver that possibility, that you can also go direct. Yeah, you can also put it in the solver directly or whatever. There are many different ways who comes to the target by end of the day. Yeah. Let's take a look to the costs. So as you know, if I come back to this one, I mean, in here, no point in the middle, in here, just 1 point in the middle. So maybe the best solution is not this one, but it is also not the as is maybe a scenario in the middle where we say, maybe one is, if I have just one, maybe it's too big, the deviations, and which kills all positive effects. So the negative are bigger than the positive effects. So it should be somehow in the middle. And to that point, I come to it. Let's take a look to the cost elements in general. Starting with outbound costs. Question in the round. Let's make it simple. Let's take, in this case, what we have not considered. Let's take to the distribution flows. So the leg behind the RDC, from the RDC to the customer's question. What is happening with those distribution costs if I increase the number of RDCs? Is it going up? Is it going down? It will go down. The more warehouses I have, the lower the distribution will be, as the shorter the distance I have. Yeah, and in here, in the case what we have just in the upstream, it is exactly the same. So the more I have, the closer I come to the RDCs, the the lower the cost will be by end of the day. Yeah. So this means also, so that's the gray line. The gray line just is decreasing. The orange line, warehousing cost, the more warehouses I have, the more fixed cost for the warehousing I have. So this is increasing. Let's take a look to the inbound. So maybe in the beginning, the inbound from 1 to 2 to 3, maybe the inbound is decreasing, but then as of a certain level, it is increasing again, as you are losing consolidation potential. And losing consolidation potential means, yeah, you rewind yourself back in order to that. We have the more warehouses we have in here, the more trade lanes we have, the less average shipments and tonnage we have running on a transport lane. And this means we are losing consolidation potential. And that's why, this is the reason why that curve is growing up again. So the question is overall, how many warehouses do I need? Where should they be located and how big should they be? Not talking about constraints yet. And this is what we have then here in an overall cost curve. And for that, a solver could help to exactly identify that. And if you have such a solver, yeah, then of course you need to know we are talking about here about NP hard problems. Yeah. So this means an NP hard problem means that it cannot be solved in a polynomial time. Yeah. So increasing the size of the problem increases the solution time exponentially. Yeah. So this is just and that's why it is also important to downsize a solver model, as you have an explosion in the end of problem size. Yeah. And whenever you downsize it, then there is a need for evaluation. There is a need in the approach again for evaluating it and put an evaluation phase after that. So this is just the theory. Okay. Let's take a look into what we have done. We have prepared a little Excel case, yeah, and I just would like to show it to you. So we have the data. You know that this has been given, and now we have created a baseline. This means we have calculated according to the costs what we have given you. We have calculated the baseline. And with in that baseline, we come to 79 million. I know, I apologize. These are not the Indian style of putting the numbers into it. This is our style. Yeah. I even don't have that possibility in Excel. I didn't find it to put those numbers in it. And nevertheless, I hope you can deal with that.
No, there's just very small difference apart from the million and lakh and crore and tens of million terminology. The only difference is the place where we use a dot, you use a comma, and the place where you use a comma, we use a dot. So just for the attendees, the only difference is we read the comma as dot. And vice versa.
Yeah, and you have also the commas on not every 3 digits, but also every 2 digits sometimes.
Yes.
Which I really don't know. I visited India. I guess I had a team. I grown up a team that time in Gurgaon. Yeah, with about 12 people, and I was there really often. Yeah, 40, 50 times. I never got familiar with this with this system. Yeah, but yeah, I hope you can deal with that. So good. So we have done all of the baseline costing. So we took a look to from where to where. What we have done here, by the way, this is Power Query. Yeah. So we put this in analytics. We have also other analytics, and in the end I can come to that. Yeah, and it can show you some examples on that side. However, this is in here, just in order to present it, we have put it in a Power Query, which is the Microsoft's ETL. Yeah, all of those green tables are just automized tables. Yeah, which we uploaded. So we have a baseline of 79, nearly 80 million. Yeah. Of course, we have collected all of the responses from you, yeah, with all of the CDC setups, and we have calculated it through. So we have calculated all of your numbers, and we have that here. Now, before I take a look to those numbers, I take a look to how we have done it. We have also used a solver, yeah. And I give you a little bit insight. I don't put in this case the full numbers in it. It just would take too long to get a result, as we need to wait sometimes 5 to 10 minutes. And I'd like to do this now in here. That's why I have downsized it a little bit to make it fast, yeah, not to wait in the call for 10 minutes. So what we have in Lockup built a cloud network, yeah, where we have in the back end a lot of services, web services, and those web services we integrate via API in other systems, in analytics platforms, in streaming platforms, so in data automation projects, but we integrate them also in Excel, that everybody worldwide can use it out of Excel immediately. This means we send data out of Excel to the back end. We let things calculated there, and we get a result back. This is the principal concept, but I don't like to go too much into detail of that. Just that you know that you know a little bit what is behind that. Yeah. So this is separate add-in, and this is in separate add-in. What is that? Got multiple. So this is in separate add-in. What you are seeing here now on the left hand is, on the right hand is the task pane bar. This is an in Excel integrated website. So this is Microsoft Edge, what is running here. Yeah. And how does it work? I give you an example. I just open a new file, not to destroy this one. By the way, you get it through the Microsoft Office store. So just insert, get add-ins, and then you can just search for it. So supply chain is enough, and you just load it in. It's no installation, it's just a local plugin. And if I just, for example, go in just that you have an idea on how this is working, I go in distance calculation. We have always those 4 steps: input data, calculation, output data, and visualization. So I just do input data, generate template. So I have here some example data from 2. Yeah, the distance calculation is something everybody knows what it is. Yeah. Calculate, now you see the green bar, so it goes to our backend, will be calculated, and we get the results back, and you have immediately for all of the lines what you put in there the route distances. And like this, we have a lot of such possibilities. I just close this file again, and switching back to here, and this is one part where we have the network design as an example, and behind the network design we have built a case, but we have not built the case just for using it one time. We have built the case in a way that we said, okay, well, this is somehow usable multiple times, well knowing maybe sometimes this I need a workaround into it, or I need that, but this is there already, can be used immediately. Yeah, so this means I go with different tables in it. In a small version, I'm just in a small version, yeah, for simplification reasons. I have here, I go here with all the sources in it. So I just put a few production plants and suppliers in it. Yeah, I just describe where they are. I just describe the costs. What would the transportation cost if I ship from there to a warehouse? Yeah, I put the warehouse in here. Yeah, and all the warehouses, I have just a few of those warehouses in here, and also here capacity constraints. I have not used them. I can also fix those and so on. I don't go too much into detail. Yeah, and also the transportation costs, and I put the customers in it and where the customers gets the volumes from. Yeah, and now if I just in this example latitude, longitude, so I have linked them already. Yeah, I can say here how many warehouses I would need. So in this case, it's just 9 warehouses, as I have just listed 9 warehouses. Yeah, the last one for the time being, I have excluded it. I come to that why. Later on, we will integrate it. So we have 9 warehouses, and I can say, please answer me all the question on how much. So this means if I take a look back to this one, yeah, it answers say, okay, from 1 to 9 is everything allowed. These are the and now please find the best out of it. And this is what we have done also in here. So I can just calculate it. What I do, I just reduce it to 1. Say I would like to have only 1. Min max is both the same. I let it calculate. So I have 3 outcomes in here. Yeah. I can export all to new sheet, so I have the full output here. I just do that, so I have all that here. See, warehouse 8 has been chosen. I see the fixed costs. I see transportation costs. So that is all there. Yeah, and I can also immediately visualize it in the map. Yeah. On screen, just coming. So immediately visualized, yeah, and I take a look to, okay, Mumbai has not Mumbai here. What is that has been chosen? Yeah, of course there is already the question. Is that right? Is that wrong? Let's take a look to the warehouses we have put in here. Yeah, so I just delete that again. Example. So I just load the warehouses in it, not the 14. So I just load those warehouses in it. Supply chain map, that long locations, push to map. So show me. Now put them on top of it. So you see now the black dots, and the black dots is our warehouses. So that's why out of the black ones, that one has been chosen. Yeah. So now if I put, for example, in indoor another one, as I see, maybe this would be better. So I see it. Solver is just doing what I tell to the solver. Yeah. So I put another one in indoor to it. Yeah. And this is 14. Yeah. And if I just increase the model by that, and I calculate it again, hold on, this was the mapping. So network design, calculate again. Running solver finished. You see how fast this is. Yeah. Open in map. Delete existing layers. Yes. Look at that. Now this one has been chosen as the best. And this is what we have. This is what we have done and what we have used in order to solve the problem on our side. Yeah. So everything which is purple in here is our scenario. Our scenarios. However, what we have done, we have not just opened it and said this is the best out of it. We have tried them all out. Yeah. So we have done, if I take a look to it, and I can take a look to the scenarios here. Yeah, we have done one CDC scenario. So we have saved all of those maps. So this is just one CDC. This is if we have just one warehouse in the middle. Yeah. This is how it would like if I have 2 warehouses in the middle. Yeah. Just 2 in the middle. This is just 2. This is if we would have 3 warehouses in the middle. So we also also just took a look to the how the structure being, and this can be done in a very short time frame. So 4, or maybe I go directly to 5 as an example. So this is the 5 setup. And of course, we have compared it and calculated against to what you have done. Yeah. So we have here also the teams on your side in it. Yeah. So if I, for example, take team 2, this is not a ranking. This is just our internal one. Yeah. Then we see exactly what you have done. Yeah. So CDCs. So you have a lot of CDCs in here. Yeah. And which means a lot of CDCs, a lot of transportation lanes. Good. Let's take a look. Franjali, timekeeper, could you quickly date me up? What is?
Yes, yes, Dirk.
How much time do we have left?
You can take another 5 minutes, because after this we just have the announcement of the winning team and then the closing. So you can take another 10 minutes.
Fantastic. Good. So taking a look to our, sometimes with 3 screens, it's even difficult to. So let's take a look to the overall, if we have that, all of our results. Yeah. And can I use, I just make it a little bit bigger. So this is just in the line one warehouse, 2 warehouse, 3 warehouses, 4, 5, 6, 7. So this means this is what you see: 1, 2, 3, 4, 5, 6, 7 DC. So we have calculated them all through. Just to take a look to the left and right. So we have here the number of DCs. We have here the transportation costs. We have here, so on the primary leg, we have the secondary leg, and we have the direct transports. So in one CDC, you see we have a high direct transportation costs because of there is a super lot deviation, and that's why a lot of those are not using the hub service or the CDC service, but just going direct. So the more warehouses I put, the lower that those costs will be. Yeah. And so on, and overall the warehousing costs are increasing. And if we take a look to that one, so we have total cost 61 million, 58, so it's going down, 57, 56.6, 56.8, 56.9, so here it's increasing again. So this means somehow the scenario 4 and 5 in our side are the winners. Now we cannot say it's 4 or it's 5 if I take a look to my business. So there are such small numbers in between. So if I take a look to my business and I know my business is increasing and next year I have even more, then I better go directly for 5, or even I go for 6 one or whatever. Yeah. So also that's why it's also important to take a look left and right. Yeah, we have calculated them through. Yeah, and this is what we have done in here. Yeah, so we got all your responses. We calculated all of the responses through. So we calculate all of the primary through. We calculated all of the secondary through. We calculated all of the direct through, and also the warehousing costs. Yeah, I don't like to show you too much, as otherwise it's you know the results already. Yeah. Good. So coming back to here, nevertheless, I would like to take to show you one more slide, which might be interesting, and then I hand over to you, Franjali.
Yeah. Yes.
This one. So this means our scenario 4 warehouses and 5 warehouses are at 56 and 56.8 million. If I say this is the best, 0% gap. Our next one, 5, is just 0.5% away from that. And the best of your submissions is 4.1% away from it with 58.9 million. And then we have another one, which is 2 away from it. And we have another one. The third one is 13% away with it, and so on. So this is just a quick outcome to that. Yeah, so if you are using a professional solver and so, you really can get something out of that. Good. So this is the best, the second best, the third best, the fourth, and the fifth best. So you see already the numbers are increasing immediately, dramatically. Yeah, and this is something, yeah, we have not validated it only evaluated it only on that. Of course, there are also some other criteria, and Franjali will now explain those.
Just one more point from my side, if you, Dirk, if you can keep the slide open. So, you know, once any solver that you use, there's no solver made which will directly give you the right result. For example, like Dirk has shown, that there are multiple scenarios that you can get out of a solver, and then you compare those scenarios, and then there are adjustments that you do in individual scenario, and that is how you get the final result. Now, the final result could be quite surprising, because if you see here, the 4 CDC scenario is the base because that is the lowest. 5 CDC scenario is slightly higher, 0.5% higher. But if you see the best one, the best, which is 4.1%, best team out of you all, which is 4.1% higher than the actual lowest one, has 14 CDCs. So you see the number of CDCs increased by 11 or 10, and the cost increased by 4.1%. So there are too many things that is going behind, you know, there are too many logics that are going behind the calculation, and it is extremely important to understand how the calculation is happening, where the valley point is coming out to be. So in any real life analytical scenario, there is no way that you can use one solver, push everything in it, get the result out, and this is your final result. If somebody would create something like that, it would be amazing, but that doesn't happen. So you actually have multiple scenarios. You actually compare what's going on in the primary side, secondary side, warehousing side, variable warehousing side, which wasn't there in our case. And then you analyze if something is going wrong somewhere, and then you find out the final cost. So that is it from my side.
Yes,
okay.
It is exactly like that. No more comments. Thank you.
Thank you. I just want to know if anyone has any questions, they can quickly ask the questions, else we will move to the next portion of rewards and awards.
Yes.
No questions? Okay, then we can move to the next section then. So